The program began in 2012 and was started by Senator Dianne Feinstein in the aftermath of the Fukushima Daiichi accident. And it started as a small research and development program within the Department of Energy and within NRC's Office of Research. And since then, it's grown to include enrichers, utilities, fuel vendors, and multiple offices at NRC, all working together to increase performance measures of nuclear fuel under accident conditions. As part of my work for the Senator on the Appropriations Committee, I took a strong interest in this program and pushed DOE to better engage private sector partners in developing and testing a range of fuel concepts. And now in my new role at NRC, I'm looking forward to seeing significant progress in this area because this technology has the potential to improve reactor safety margins and therefore increase social acceptance, along with the potential to increase plant economics. I've been very impressed with staff efforts to date. The NRC is committed to enabling the safe use of accident-tolerant fuel technologies and their associated enrichment, fabrication, transportation, and storage aspects. And I've been really impressed about how the different offices in the agency have come together to ensure we're ready for the future. I don't want to take any more time because we have a great panel today, and I want to provide you with the opportunity to ask them questions. I'll ask the panel to start with brief 5-minute statements, and then in the course of an hour or so that we have together, I hope we can draw out from them some broad range of answers or thoughts on accident-tolerant fuel. We have a great panel for you this morning. We have Marilyn Diaz, project manager with the NRC. We have Steve Cowne with Urenco. We have Robert Dahm with the Electric Power Research Institute. We have Zach McDaniel with the Westinghouse Electric Company. John Williams with Southern Nuclear Operating Company. And I think we're going to have a great discussion. I'll invite first Marilyn Diaz to give us her thoughts on the current accident-tolerant fuel environment at the NRC. As I mentioned, Ms. Diaz serves as a project manager in the Fuel Facility Licensing Branch, Division of Fuel Management, Office of Nuclear Material Safety and Safeguards, what we refer to as NMSS. I want to take this opportunity to thank Marilyn for her efforts in planning and coordinating this session. She's done a great job getting us ready, and I really appreciate it. Marilyn?
Can you guys hear me? Great. Thanks, Chairman Hanson, for that introduction, and good morning to everyone that is joining us today. I will be presenting on behalf of the great NRC team that continues to work to ensure the safe use of these accident-tolerant fuels. Slide 1. Let's start quickly with some of our major accomplishments in the last year, making sure that we cover the whole fuel cycle. The first thing, on the enrichment of fuel, NRC approved a license amendment to Louisiana Energy Services, allowing them to enrich up to 5.5 weight%. On the transportation of uranium hexafluoride, or UF6 as we refer to, we have held a couple of pre-application meetings discussing a potential submittal of a design for transporting UF6 with higher enrichments. On the fuel fabrication side, staff review and approved GNFA's minimum margin of subcriticality for enrichments up to 8 weight%. This is an interim step towards a future license amendment request to allow processing of ATF above the 5 weight%. On the side of the transportation of fresh fuel, we've completed several actions. For example, we completed a review to allow the transportation of fuel rods with chromium-coated cladding, doped pellets, and fuel rods enriched up to 7 weight%. On the Parts 50 area, we've completed several actions as well. To note, we issued the interim staff guidance on chromium-coated cladding and held a phenomena identification and ranking table, also known as PERT, exercise for severe accidents. On the spent fuel side, we approved a revision to a certificate of compliance to allow transportation of spent ATF rods. Next slide, please. The NRC staff is approaching ATF fuels licensing differently than the past. To prepare for both near-term and long-term ATF designs, the staff has established a new paradigm as described in the project plan. The old paradigm, as shown in the slide, has industry and staff developing the technical basis. Then in a series of sequential steps, staff would develop guidance, update confirmatory codes, and build on expertise so that we will be ready for any regulatory activity. The new paradigm, as described in the project plan, takes on innovative approaches and have many of the steps being conducted in parallel. If you click on enter on the slide, I think we'll see the new paradigm. Thanks. Great, there you have it. We have the development of guidance, confirmatory codes, and staff expertise in parallel with industry efforts to develop the technical basis for ATF. We're also doing work in advance of regulatory actions. For example, we're conducting PERTs to inform guidance and build staff expertise early. As mentioned in the previous slide, the staff completed a PERT for coated claddings, which led to the interim staff guidance on coated claddings. In addition, in September, another PERT was conducted to address the performance in severe accidents of the current ATF concepts, high burn-up fuel, and fuel enrichments above the 5 weight percent. The report is scheduled to be completed in April. We're also being proactive in our activities by obtaining information we need via research, literature reviews, and code enhancements to ensure readiness while we process topical reports and applications and use risk-informed approaches in making decisions. We have completed 5 literature reviews so far, and there are more to come. We're communicating early and often. We're conducting public meetings, updating the project plan regularly, conducting pre-submittal meetings, and attending conference and workshops to keep up with the latest information and continue early engagements. The staff has and will continue to use innovative approaches to support licensing for ATF. One innovative approach used was the development of the critical path timeline, identifying when fuel cycle facilities and transportation packages, applicants and licensees will need to submit an application to support their accelerated schedule. This helped the NRC identify review times, resources, and prioritize the licensing actions. A second innovative approach is the NRC's participation in EPRI's CRAFT research framework to address ATF behavior and performance. All of these activities have an ultimate goal of ensuring preparedness to review licensing actions for the near-term technologies, increased enrichment, and high burn-up. That's all from the NRC. I'll turn it back to you, Chairman Hanson. Thank you.
Thanks, Marilyn. Now let me turn to Steve Cowne. Steve has over 30 years in the nuclear industry, and he's currently the Chief Nuclear Officer for Urenco USA, also known as LES. Today, he's going to provide us a quick overview of Urenco USA's efforts in the ATF area. Steve?
Thank you, Chairman Hanson. Appreciate the introduction. Again, this is Steve Cowne, CNO with LES, and we own and operate the only operating enrichment facility in the United States in Eunice, New Mexico. We provide enriched UF6 for the fabricators to make fuel for our customers, the utilities. Now, back in 2020, our company, Urenco, initiated 2 projects, one at our LES facility and one at our sister facility in Great Britain, Capenhurst, England. And this is the LEU Plus project, we call it. Now, we define LEU Plus as the gamut of enrichments between 5 weight percent and 10 weight percent. Anything above 10 weight percent we define as HALEU, and that's a different project altogether. From a plant standpoint, the core technology that we use for centrifuge in the form of centrifuges will efficiently produce just about any assay that you need. Our plant may need some slight modifications to produce accident-tolerant fuel for the industry, but most of the effort will really be licensing and analytical in nature. We expect that we may have to change or revise some of our IROFs, our items relied on for safety, and those will be the core consideration in the license amendments that we submit to the NRC. Next slide, please. There's 3 main challenges that Urenco USA sees in producing accident-tolerant fuel, specifically for the enrichers and fabricators. Number one, we see competing resources occurring at the NRC when they have to concurrently review license amendments from both the utilities, the fabricators, and the enricher. We're also needing more information from our customers, the utilities, providing the quantities of material that they would need, the assays of the material, and any target reload dates that they have as an objective. Finally, one of the most challenging issues that we've got, and Marilyn referred to this, is the transportation of the UF6, of the enriched uranium hexafluoride. Currently, the industry does that in 30B cylinders, which are only licensed up to 5%. So to ship LEU+, we need a different transportation package, or we need to prove and to relicense the existing 30B. Now, Urenco's been working with an outside vendor to potentially modify a 30B cylinder and the DM30 overpack that goes with it so we can ship the LEU+. But we're also looking at the existing 30B cylinders to see if they can be relicensed for greater than 5 weight percent. Regardless, we think that's going to be an industry effort that's needed in order to address the transportation issues. So, Chairman, those are the only comments I had this morning. I appreciate the few minutes. Thank you.
Thanks very much, Steve. I really appreciate it. Now we'll hear from Zachary McDaniel from the Westinghouse Electric Company. Zach is leading technology development for the Westinghouse Accident Tolerant Fuel Program and has held multiple leaderships at Westinghouse since 2006. Today, he's going to talk to us about Westinghouse's ATF efforts. Zach?
Thank you, Chairman Hanson. Appreciate the opportunity to share with the group here today and participate on this panel and provide you with an overview of the advancements Westinghouse has made as part of this overall industry effort to develop accident-tolerant fuel products. Next slide, please. We'll start with an overview of the portfolio of our Encore fuel program. So these are the real drivers, the real products that result from this program. We broke this up in 2 primary areas that we're working on, and the fuel is comprised of the cladding and the actual fuel material. So we're working in both of these areas on short-term and long-term products with the ultimate goal of providing both economic performance for the utilities and for Westinghouse, and also increase that safety performance, which was the initiating cause, which Marilyn discussed in her initial comments. So we'll start with the initial products we're developing, the short-term products, which we have experience with now through some commercial campaigns with some utilities, and also working to get licensing documents into the NRC for review and get these products to market quickly in the next few years. So the cladding short-term product is a chromium-coated cladding. This is similar to the other fuel vendors, but we are working here to increase the safety and operational margin, and also really tying this into the current industry drive towards high burnup. So we feel that this could provide additional margin there, and we're currently exploring that with EPRI, NEI, the utilities, and others. For the near-term advanced fuel product, we're looking at a doped pellet. So this is where we get a DOT. So this really provides some of those economic and safety benefits as well, in that we get the higher density. So we get more uranium in the core, allows more fuel management options for the utilities. So that supports the fuel cycle cost and may also enable this high burnup drive to help implement these fuel products in the short to near term. In longer term, we're partnering with General Atomics for the silicon carbide development. They have a product here, the SIGA silicon carbide cladding. So this is of interest to us. We're also partnering with utilities here to have a short-term demonstration to get this product in the reactor, get some commercial irradiation experience. And longer term, for the advanced fuel pellet material, we are looking at uranium nitride. So again, these are also efforts that we're interested in engaging and driving forward, but really focused on the interactions with the NRC right now on the short-term products for the ADOPT and our chromium-coated cladding. Next slide, please. All right. So the crux of the Westinghouse engagement are overall strategic driving areas. So mentioned before, we're really focused on the near-term products. So we want to get these towards commercialization as quickly as possible to provide value to the industry and to Westinghouse. How we are getting there is we're demonstrating our performance through the testing of these materials and commercial irradiation experience and outside of the commercial reactors, additional test experience, and getting that post-irradiation examination to feed into the topical reports to demonstrate the value that we anticipate from these products. So we have campaigns underway. We have some experience recently from material that has went through a cycle of irradiation, performed well according to our expectations, and even saw some benefits that were not expected outright. And we have other irradiations planned and commercial experience anticipated. So working through finalizing those contracts now. So mentioned before, we have topical reports into the NRC. We recently submitted, the past year, we submitted a topical report for our Adopt product. So that is currently under review by the NRC. And also the first step in moving to the higher burnup, we have an intermediate burnup extension topical report, which has also been accepted and is under review by the NRC. So working closely there to build these products up for implementation, ultimately get to this higher burnup and the higher enrichment strategy that the industry is investigating right now, which is that last bullet here under this near-term product development is really working closely with the DOE to incorporate the industry goals and drive toward this regime in demonstrating the benefits that these products we've developed under the accident tolerant fuel portfolio can provide assistance in bringing us there safely through the NRC review. I'll mention briefly, mentioned on the previous slide, where we're developing the silicon carbide with GA, working closely with the national labs for uranium nitride development. So we're really focused as well on driving the advancements in these revolutionary ATF materials. So see what operational benefits they may open up for the utilities. So we'll stay engaged with utilities there as we develop these products and see how they fit into their operational strategies. And lastly, coordinating the ATF activities for the DOE alignment. So this is essential. This is a very aggressive schedule that we are on. It's manageable for sure. And we have engagement with all the key parties developed, frequent contact with the NRC. They're aware of our risk and the real drive to expand to these higher burnup conditions. Marilyn mentioned before the risk-informed approach that we hope to do, partnering with Rob and our EPRI colleagues and NEI and our colleagues in the industry to really drive that analysis for the high burnup evaluation. And also want to stress it is important, and due to the contributions from the DOE that we're able to continue at this pace and develop these products in this timeline. So that continued funding from the DOE is necessary and needed to keep these products developed at the schedule they're currently on. So that's all for me, Chairman. Appreciate the time.
Thanks very much, Zach. So now let me turn to John Williams, who's the Nuclear Fleet and Analysis Director for Southern Nuclear Operating Company. In his role, he's responsible for nuclear fuel and safety analysis for the Southern Nuclear Fleet of generating plants. Mr. Williams' presentation is titled "The Case for Accident Tolerant Fuel, a Utility Perspective." John?
Hey, good morning. Let me begin by thanking you, Chairman Hanson, and the NRC staff for the opportunity to speak today regarding utility interest in accident tolerant fuel. I'd invite participants to use the Q&A feature to submit questions while I'm speaking. Next slide. For the last several years, I've had the privilege to be part of a team of utilities, fuel vendors, engineering firms, EPRI, and other research groups with the purpose of evaluating the performance of accident-tolerant fuels. During these evaluations, we've learned that ATF has the capability of improving operational fuel reliability. It provides operators critical time during the early portions of a postulated event, and has shown that it can improve the core damage frequency of our fleet by as much as 10%. So given the added robustness of the fuel, we turn to look at how that margin could be used to provide operating flexibility to the plants and perhaps reduce cost. Fuel cycle improvements, including increases in enrichment and burnup, emerged as the benefit that had the most generic application to the fleet and provided the magnitude of savings necessary to encourage and accelerate implementation. My EPRI colleague, Dahm, will show you in just a minute how U.S. plants have been pushing the limits of enrichment and burnup with our core designs. So U.S. pressurized water reactor today, their core designs for 60% of that fleet are currently limited by the enrichment limit of 5 weight percent. So by increasing enrichment and the subsequent burnup limit, we can lower our fuel costs to our customers. We can reduce the amount of spent fuel being produced by the U.S. fleet. Additionally, higher enrichment and burnup can finally allow for large, high power density PWRs like our plant Vogel to transition to 24-month operating cycles, which will increase the carbon-free electricity generation of the U.S. fleet. Given the benefits, next slide, please. Given the benefits, both in safety and economics, utilities have been actively loading lead test assemblies into reactors since 2018. That's 4 years ahead of the original timeline. This work furthers our understanding of the technology and provides the needed information to support licensing. Last year, Southern Nuclear harvested ATF samples that operated for 2 years in Plant Hatch and shipped them to Oak Ridge National Lab for detailed examination. Wider adoption and participation of ATF by utilities is occurring as shown on this slide. By the end of 2021, 9 different ATF technologies will be in operation in 8 reactors by 4 different utilities. I think it's important to note for utilities to continue to move forward, it is imperative that we see a successful licensing path for this innovative fuel technology and a successful licensing path for the implementation of the benefits. Specifically, we need a line of sight to the resolution of the challenges to implementation of higher burnups. I am often asked where I think the industry will end up with this program. It's going to be difficult to predict, as I expect this program will continue to evolve to meet the needs of the industry. What I do know is that significant innovation and development has gone into nuclear fuel in the last 10 years. Our fuel will be higher performing and safer when we finish, and these benefits will ultimately improve the safety of our plants, but also bring improvements to operating flexibility and cost effectiveness. Thanks for the time this morning, Chairman Hanson, and I look forward to our discussion.
Thanks very much, John. I appreciate that. Next, we'll go to our next panelist is going to be Dr. Robert Dahm from the Electric Power Research Institute, better known as EPRI. Dr. Dahm is a senior technical executive in the Fuel and Chemistry Department within the nuclear sector at EPRI. He leads a research development and demonstration program associated with advanced technology fuel, including accident-tolerant fuel. Dr. Dahm is going to provide us an overview of EPRI's perspectives and research activities. Rob?
Good morning, and thank you, Chairman Hanson, and thank you to the NRC for inviting me to participate in this panel. I would briefly like to present some takeaways from the studies that EPRI has conducted to understand the benefits, risks associated with accident-tolerant fuel for light water reactors. John referenced some of those studies in his opening remarks, so let me give you a little bit more detail. EPRI worked closely, if you would go to the next slide, please. EPRI worked closely with key industry stakeholders in the research community to analyze the potential safety, performance, and economic benefits, as well as assess any risks of accident-tolerant fuel relative to the current fuel technologies. In doing so, these collaborations and the resulting conclusions help to inform the business case for the industry to consider accident-tolerant fuel deployment. One of the key conclusions indicated that improvements to safety and performance margins are likely to result with the deployment of ATF over the current technologies during normal operations, anticipated operational occurrences, and postulated accidents, both design basis and beyond design basis accidents. By considering how fuel technologies have innovated since the beginning of nuclear power generation, Near-term ATF technologies, along with increased uranium-235 enrichment, may also enable higher fuel discharge burnup, similar to how the other evolutionary changes resulted in the current technologies being used today. More revolutionary or longer-term ATF technologies may further extend these possibilities. Combining all of these findings indicate that improvements to safety, performance, and efficiencies may be realized through ATF deployment. Of course, these and many other studies have identified various gaps to further quantify these margins, as well as refine the conclusions from these benefit and risk analyses. There are numerous public-private collaborative partnerships in the US and internationally, with the ultimate goal to perform targeted research to further inform the technical and licensing bases for deploying ATF with increased enrichment and higher discharge burnups, according to the needs and timelines of the industry's submittals and the NRC's review of those submittals. And then to the next slide, please. Here I've listed in no particular order several high priority generic issues that are gaps for ATF with increased enrichment and higher burnups, as identified by both the industry and the NRC. First, how does ATF with increased enrichment and across the entire burnup spectrum behave during severe accidents or beyond design basis accident conditions? As I mentioned, this research would help to refine the various analytical safety studies performed over the past few years. Fuel fragmentation, relocation, and dispersal, also known as FFRD, is a phenomenon that has been observed in higher burnup fuel during simulated local conditions. So there are ongoing research efforts to further investigate FFRD and its consequences. There is a need to analyze the enrichment, transportation, fabrication, and storage capabilities across the entire fuel cycle for increasing uranium-235 enrichment above the 5 weight percent that we have today. And you heard Steve mention some of that in his opening remarks. Next, how does ATF in high burnup behave under normal reactor operating conditions? And how does it avoid fuel failures due to reactor water chemistry interactions, fretting, pellet clad interaction, as well as other operational issues due to crud deposition and distortion? And lastly, how does ATF and higher burnups affect back-end issues during wet and dry storage, as well as spent fuel transportation and eventual disposal? You heard in past conferences, even other sessions during this year's conference, and perhaps read recent publications that there are opportunities to evolve strategies, methodologies, and technological advancements towards streamlining the development of technical bases and fuel licensing. First, with the closure of some irradiation and post-irradiation examination facilities around the world, there is a need to collaborate, cooperate, and coordinate research activities to not only lower costs across all stakeholders, but also to provide more timely research results and lessen the burden on those surviving but overprescribed facilities around the world. Development and adoption of risk-informed methodologies for fuel licensing beyond the traditional deterministic and best estimate methods, some of which you've heard today during this session. But there was a very good session led by Mirella Garvelis yesterday on this topic, and particularly how the NRC is using risk-informed decision-making. And then lastly, coupling past, present, and future experimentation with modeling and simulation tools that have leveraged advancements in computational material science methods. Those, I hope that gives you some perspectives of the benefits and risks associated with ATF, increased enrichment and higher burnup, while also highlighting the research needs and activities to help the industry and the NRC improve the safety, performance, and economics of the LWR fleet now and for years to come. Thank you, Chairman. Those are the end of my remarks.
Thanks, Rob. I really appreciate that. We've had a series of questions come in while folks were presenting, and I think we're going to have a very interesting discussion. Oh, good. There's everybody on the screen. So let me get started here. This is a kind of a two-parter. I think the first part of this is going to be for Marilyn, and the second part is for Zach. And it's, what is the NRC doing to prepare for ATF, increased enrichment and higher burnup? And how's the industry enabling the safe use of ATF? Marilyn?
Thanks, Chairman Hanson. As I mentioned through my presentation, we're making progress to ensure efficiency in our reviews. We're effectively implementing strategies identified in the ATF project plan. We're also encouraging early engagement and frequent communication related to future submittals. And we're continuing frequent communications and interactions with the nuclear industry, DOE, members of the public, and other stakeholders to make sure that, to ensure our readiness and be prepared for the licensing actions for ATF, increased enrichment, and high burnup. Thank you.
So let me just jump in here real quick before we go to Zach. Marilyn, John mentioned earlier the need for kind of a regulatory line of sight for licensees on ATF. Are those project plans that you mentioned kind of is the objective of those to provide that line of sight, both kind of within the NRC, but also externally?
So the project plan, what it presents is the new paradigm. How are we making sure that we are ready? It presents our strategies on how do we ensure readiness by assessing a regulatory framework, assessing our guidance, and really communicating to the industry how do we intend to approach this. And really it's a lot of early engagement is what we encourage to make sure that we understand what they're planning to submit, and we ensure our readiness by either communicating to us their basis, their technical basis, or whether we need to go out and do some research. So that's all presented in that ATF project plan to ensure that our regulatory framework is there to be able to license those ATF applications.
Great, thank you. Zach, let me go over to you then for the kind of the second part of that question about how industry is enabling the safe use of ATF.
Sure. Yes. And I would like to echo a lot of the comments that Marilyn just made. It's the early interaction with the NRC, presenting the strategy that we have laid out that aligns with the implementation schedule that we have coordinated through EPRI, through the utilities, through NEI. So there's a two-part way that we work with NRC to ensure that we are approaching safely. There's Westinghouse specifically, where we go in one-on-one, and it's also through the industry collaborations led by EPRI, led by NEI, that we work through to help develop the criteria for FFRD, the risk-informed approach, which we're currently discussing, which Rob mentioned. As well as going to that higher burnup and how we plan to do that Westinghouse specifically. So we just spoke briefly about how we're doing it as an industry through the groups and coordinating those joint proposals. Also, through Westinghouse specifically, we've broken it up into two stages. Our strategy there was the intermediate burnup extension, which we submitted last year. So we laid out the strategy with the NRC. We put that plan in place to take a smaller increment of that burnup extension, to extend that, to demonstrate that we understand the phenomenon that happened beyond the current licensed burnup limits, which helps facilitate the framework and the structure that we'll use ultimately get to the higher burnup goals that the industry is currently after.
Very interesting. Thank you, Zach, very much for that. The next question we've got is for Rob Dahm. And, Rob, you laid out a number of kind of research needs, important areas to look at. But what do you think are the biggest challenges you see to actual deployment of ATF and higher burnup and higher enrichment fuels?
Yeah, that's a very good question. Certainly, as EPRI is a research organization, we work closely with the research arm of the NRC. And as I mentioned earlier in my remarks, there have been challenges in terms of various facilities being shut down over the past several years, particularly irradiation test reactors, as well as the hot cell facilities for conducting post-irradiation examinations. And those facilities are very much needed to help fill those material behavior data needs as well as those material property needs. And so in this country, of course, the Department of Energy has stood up a number of new capabilities as well as resurrected older capabilities, in particular treat and access and ATR, as well as HIFER, have allowed some of those irradiations to go on and get a sufficient amount of neutron fluence as well as burn up achieved, so that we could better understand, well, what are those changes in margin relative to the new technologies. So as more materials become available from the commercial reactor irradiations, such as the ones in Hatch that John referenced, those materials will go to those post-irradiation examination facilities, and there will be challenges in performing all the PIE that is needed. So that is one aspect of challenges going forward.
Yeah, very helpful. Thanks, Rob. I really appreciate that. So, Steve, you mentioned that increased enrichment is predominantly a licensing issue, but aren't there technical challenges that need to be addressed with regard to criticality safety? And if there are, can you say some more about that?
Yes, Chairman. That is correct. There are some challenges from a criticality safety standpoint. For example, some facilities like ours will use for criticality safety something called safe by design components within the plant. If you increase the assay or the enrichment level of those safe by design components, you may have to change the physical characteristics of those components by replacing them with smaller or different geometry, et cetera. So when I said there might be some slight modifications, that's the type of thing that could be seen, at a facility like ours, is changing out pumps or chemical traps or something like that to make them, safe from a higher assay standpoint. There's also analytical ways to address those issues, and there's also with our IROS, or items relied on for safety, we can look at what we call administrative IROS, which are procedure-based, human performance-based type IROS, and replaces some others that are currently being used. So there's a bunch of tools in our toolbox that we can use to address those. But overall, the piping system, the centrifuges, and everything else, they can easily handle, a few percentages higher for the fuel. Right now, we can make up to 5.5%, and we see for ATF going up a couple of more percentage points in order to help the industry out.
Thank you, Steve. Yeah, I really appreciate that. Zach, I think this next question is for you, but I think it's also going to be partly a question for Rob, as he talked about kind of international testing capabilities. But the primary question I think I have is, what kind of international experience is there with ATF that we can draw on here in the U.S.?
Mm-hmm. Yeah, this is a good question. Thank you, Chairman Hanson. It is something that we have fielded interest from globally. And there is developments globally. If you look at the global fuel vendors, they're all developing some form of accident-tolerant fuel product. It is a global product and a global demand. One thing that we've encountered through our experience is there's different industry drivers that are pushing for the needs for accident-tolerant fuel in the different regions of the world. So what we're looking for in Europe and country to country is something slightly different than what the drivers are in the U.S. In the U.S., we are looking for that improved safety analysis, but also the economic benefit. So that the economic benefits are key to drive, and that's really pushing us towards the how we can enable the higher burnup and the higher enrichment product. In Europe, the operational needs of the utilities are not the same as in the U.S. So there's not that same drive towards a longer fuel cycle, but it's focused more on ironing out the safety analysis benefits. So what can we get there in additional safety margin? And then in the other regions of the world, they're also looking at the technology and still determining what the market need is for that and the safety benefits they want to capture. So yeah, it is definitely specific to the utility, the market that utility is, and what benefits they're after. But our global program is set such that our single product can provide those benefits for all of the regions globally. So yeah, thank you, Chris. Great question.
Thanks, Zach. Rob, did you want to add anything there?
Yeah, I agree with Zach, and of course, particularly with the aspect that various countries, the utilities, regulators have different understanding of ATF technologies and what they can do in terms of bringing added safety. So there is a growing interest in ATF around the world. And with that, there is a growing interest in performing research as well. So, of course, we've enjoyed our relationship with the industry and the NRC and collaboratively pursuing research around the world, particularly through OECD NEA and IAEA. And that certainly is going to expand over the next several years to help provide more data. So yes, there is a much growing interest from the international community as well.
Okay, great, thank you. You know, we've had a kind of a series of specific questions for each of you, and I've got some more that are kind of coming in on my other screen over here. But I did kind of want to back up, and I want to start with John on this question. You know, as I'm listening to each of you speak, and I think about the supply chain for fuel and how highly optimized it is, right, from enrichment to fabrication to the plant, and how far in advance, you know, plant managers have to make orders, thinking about their next series of outages. It almost appears to me to be kind of a complex set of chicken and egg problems. And I'm wondering, for John, you know, how do you start to make those decisions at the plant or even at the fleet level, right, which is kind of where you sit, about how to transition to these technologies? Certainly, the regulatory aspects are going to be part of this, but you know, as we know, fuel fabrication facilities are highly optimized, enrichment facilities are highly optimized, and we're talking about making not insignificant changes to those facilities as we go along. So how are you thinking about that problem as we move potentially into this space where we're, you know, we've got fuel with higher performance margins, higher burnup, higher enrichment, et cetera?
Well, I find it funny you referred to it as a chicken and egg problem, because I've referred to this as the greatest chicken and egg problem we've ever faced. You know, if I'm an enricher and I'm a fabricator, I'm not going to make capital investments or licensing investments in my facility until I know that I have a customer that's going to take that product. Mm-hmm. So they're going to wait for us to come and lead the way. What we do know about this change is it's too big for any one utility. So take the enrichment problem alone. The enrichment in change, we believe there's a critical mass, forgive the pun, of about 15 units that are needed to foster the investment necessary for that change. So that's where we are, you know, and that's kind of why we've been working together on this problem as part of NEIs to understand the benefits so that each utility can assess what will be their costs and the benefits to their customers and make decisions really on a plant by plant basis, and then provide that input to the fabricators and the enrichers. And if there are enough utilities that are interested, then we'll see them make that investment, and we're going on. But again, you know, I mentioned this in my talk. It's more than just a cost benefit. There's a lot of regulatory changes that have to be made here. So we have to see that the technology, the benefits, all of those things, that there's line of sight to getting all those before the utilities are going to make an investment. But we are coming up on the time. You know, we're looking for deployment in the mid-2020s. We are at the time where the utilities are going to have to start thinking about making those investments and making those commitments to the enrichers and the fabricators for the product. And so, you know, it's a critical time in the juncture for the utilities to get the right signals from the fabricator and the right signals about a licensing success path so that we feel comfortable making those commitments to move forward.
Yeah, that's very helpful, right? From the NRC standpoint, we're often in receipt mode, right? For technical reports and other kind of licensing actions. Certainly, I think Marilyn spoke well about the project plan and about how we're kind of getting ready. So my hope is that, and I think Marilyn's nodding along too on this, that we're sending the right signals about that, even if we don't have a fully kind of laid out and detailed roadmap. So that's thanks. That's very interesting. Zach or Steve, do you want to jump in here on this?
I'll let Steve take it. My initial thought on this was, if there is an interest from the utilities, that we'll find a way to make it happen, right? If it's in the best interest of the industry and moving forward, I think we'd work with Steve, and Steve and Urenco would build out those capabilities if there is sufficient market demand. But yeah, and that's the way we see it at Westinghouse. It's a big picture type thing.
Sure.
Yeah, John hit the nail on the head about the chicken or the egg. And so did you, Chairman. We often use the phrase, who's going to jump first? And so what we're trying to encourage the industry to do is to hold hands and jump together off the end of that pier. So we have at Urenco made some investment into the LEU Plus project. We're going ahead with the licensing of that. We believe that there's going to be enough of a interest in the market in the U.S. That we will be able to enrich and sell accident tolerant fuel level assays and higher burnup assays. There is some risk associated with it. When you start talking about small modular reactors and in HALEU, assays between 10 and 20%, that has a little bit higher risk from a commercial standpoint. And that's another example of who's going to go first, the SMRs or the enrichers or the fabricators, whatever. But these are interesting times in the fuel cycle.
Absolutely. Yeah. Certainly it is. We could talk all day about all the different aspects of this. Marilyn, I've got kind of a technical question for you, but I think it's a really interesting one about the IAEA and about we're looking at new claddings outside of kind of a long history of zircaloy, and are these claddings being recognized by IAEA and the additional protocol?
Thank you, Chairman Hanson. From NRC perspective, we would not expect that the designation of zirconium tubing would change due to the application of a thin chrome coating. However, my limited experience with the IAEA protocols, IAEA controls these protocols. In my opinion, it will still be treated as fuel. But as far as the NRC, we would apply our current regulation to ensure that the fuel performs safely, and it's up to the applicant to demonstrate safety and compliance with the NRC regulation.
Okay, great, thank you. And John, what do you see as the spent fuel? One of the benefits of ATF and higher enrichment and higher burnup is potentially less spent fuel generated. Is there a ballpark number around that operators can see, could look forward to in these scenarios?
Yeah, so, and I think there was a number on my slide, and it's a big number. It's in the billions of dollars in terms of spent fuel cost reduction over the remaining life of the fleet. That's a big number. And frankly, the big winner in that number is the American people. As the Department of Energy has the responsibility to take and dispose of that fuel. And so our customers have the benefit of us generating less, but also, there'll be less to need permanent disposal. It's in terms of number of assemblies, I mean, it's a large number. It's a significant reduction, about 20% reduction in the fuel in the spent fuel that would be generated.
Wow. Yeah, that is significant. Very, very, very interesting. So Zach, let me go over to you. You mentioned using a risk-informed approach for ATF. Obviously, it's something that Marilyn touched on as well. But can you talk about how kind of Westinghouse is approaching risk informing its analyses on this subject, and kind of what's the time frame that you see for engaging in that and completing that those risk informed analyses?
Mm-hmm. Yeah, very good. Thank you for the question. So this specifically, the risk-informed approach I was referring to, is something that's being led by NEI and EPRI. So it's something they're working to put forth that we would build upon for our topical report, specifically addressing the FFRD criteria that Rob discussed in his presentation. So our participation or our interest in that is to see that move forward, for that to be further evaluated to change the way we can license our product and to get these products to market quickly in alignment with the industry goals. So it's really, for this specific approach, it's a collaboration that benefits the whole industry, and we would take and build upon that for our specific topical report.
Okay. Yeah, very good. Thank you. I appreciate that. We talked about the chicken and egg problem, the who jumps first problem, as Steve put it earlier. But there is a potential opening there with the start of operations for Vogel 3 and 4. So, John, is this something that Southern may consider for Vogel 3 and 4, or do you think the timing isn't quite right, that you'll start on kind of one footing and maybe potentially shift down the road?
So we're focused on finishing the construction of that plant and getting it online later this year, which is very exciting. And that plant is licensed with what I will say are the current fuels. And so we plan to operate that with the current fuels. Then we'll go through the process of evaluating the benefits relative to that plant and its technology. It has different technology, so we've got to make sure it would make sense to provide that benefit. So I think the answer is it's licensed to operate with the current fuels. That's the plan. And we'll evaluate changing to these fuels later on down the road.
Yeah, great. Thank you for that. I appreciate that. Zach, Westinghouse has a history on kind of multiple portions of the fuel cycle. One of them is certainly the back end and spent fuel management. So, how does future spent fuel management play a role in the design of ATF? Are you thinking about kind of how does the after use scenarios factor into the front end of fuel design for you all?
Yeah, definitely. And as John mentioned, that's one of the key drivers to look at the higher burnup product that we're looking to develop, is reduce those back end costs. But yeah, it is factored in through all of our assessments and before we can even put the material in the core. So working closely with the NRC and internally as well to evaluate the materials that we're developing, the impact on the spent fuel pool criticality analysis, even for the initial test rods and the test assemblies that we're inserting. There is a very specific analysis we have to do, and the impacts we have to assess for those campaigns. So we've experienced that through the 2 campaigns we already have underway, the 2 additional ones we're currently working on. So it is something we definitely factor into, and one of the key drivers in industry interest in that high burnup ultimate use for these products, and how we can realize that benefit and demonstrate additional benefits for the product.
Mm-hmm. Mm-hmm. Yeah. Very good. Thank you. One of the questions I want to ask all of our panelists, and Zach, you touched on it in your presentation, is about Silica Carbide fuel and the Silica Carbide cladding, and where does that kind of fall on the spectrum of activities or opportunities for for accident tolerant fuel, high enrichment, higher burnup. Does silica carbide, we've seen, I think in the presentations today, that, you go to chromium cladding or chromium doped fuel and you get to that, what Steve calls LEU plus type of a situation. But does silica, and these things kind of fit together, and we're starting to understand plant operations and so forth. But then how does that look different for silica carbide? And that's kind of a question for all of you. I mean, any one of you can kind of start. Zach, you might start because you had it in your presentation, but I'd love to hear kind of Rob and Steve and John weigh in on this as well.
Yeah, and this is the silicon carbides. When you really drive into the ultimate accident tolerant benefits, you're going to get to silicon carbide. So that's the end state, the end product that really delivers all the benefits this program set out to do. We mentioned before that was a longer term product. So it's something that's not going to be implemented in the next few years. There's still some technology readiness, technology development that needs to occur. We are working to get this in a reactor. So we're working closely with the utility here. It hasn't been formally announced, I believe, but we are working to get that commercial irradiation experience for this material and to further develop it. But there's benefits in developing it for the existing LWR fleet as well, because it builds that maturity for the product and ultimately will help better position the United States for the advanced reactor campaign. So we see these products as also being valuable to the advanced reactor designs and the fuel products that will ultimately support those. So it has multiple benefits. What we learn here for the existing fleet could help support the United States future fleet as well.
Okay. Thank you. Rob or Steve or John?
Yeah, if I can chime in. Certainly Zach hit the nail on the head with silicon carbide being probably the most resistant to accident tolerant or accidents, so most tolerant to accidents. That is by far the major benefit of it. But there's other benefits. So not only under severe accidents, but AOOs and DBAs. Those behavior of silicon carbide is very stable after a certain amount of irradiation. You don't have to worry about corrosion. You don't have to worry about hydrogen pickup, and certainly dimensional stability or distortion is also well understood after a cycle or a cycle and a half. And so those are additional benefits that tend to allay any concerns during all operations through accident conditions.
Okay, great. Anyone else want to touch on that?
Sure, Chairman Hanson. I'll just add that we've been evolving and developing our fuels for the 40 years that we've been operating our plants, and so I don't see that stopping. And I think the timeline of the different products that Zach went through in his presentation really shows you. I think we're getting a glimpse of what the future of nuclear fuel might look like as we have some of the near-term products in the short term of the middle part of this decade, and then obviously the more advanced projects like the silicon carbide, perhaps in the early part of the next decade. And so, we're interested, from a utility perspective, we're interested in products that bring benefits and value to our customers. So we're going to continue to look at what benefits can come from these advanced fuels, and we'll deploy them when the technology is ready and they're ready to go into our plants.
Okay, great. Thank you for that.
And Chairman, from an enricher standpoint, obviously we don't get too involved into cladding or the silicon carbide or et cetera. That's more the area for Zach and other fabricators. We do work closely with fabricators to make sure that they get the type of UF6 that they want. They get the purity levels that they want. There is a quality associated with that, and that can impact the fuel manufacturing process. So, but otherwise, from an enricher, not much impact on that.
Thanks, Steve. I appreciate that. I want to, we've talked about some of the kind of operational benefits and economic benefits. And, well, there's the operational benefits, and there are kind of two sides of that coin. One is potential economics. The other one really is kind of safety. And I think there's some concern out there in the world that the safety benefits achieved by these different doping or cladding technologies that we're adding to the fuel then are offset in a way by going to higher enrichment and higher burnup. And what I guess my question is that a zero-sum game for your all's view? And how does kind of the net increase, how do we maintain kind of the net increase in overall safety as the part of the use of these technologies? And that's kind of a question for Zach, partly I think for John, but also certainly for Rob too. He may have some thoughts from EPRI's standpoint on this.
Sure, I'll go ahead and kick it off, Chairman. So yeah, completely agree, and that is something that we are keeping in mind and in our forefront as we develop these products and ensure that the safety analysis benefits or the safety margins that we're building into our products through the implementation of these is maintained throughout the life of the burn up of these products that they're currently licensed to and that we wish to extend them to. And we're doing that through collaboration, openness with the industry as a whole, including the DOE, the NRC, the utilities, and EPRI, NEI, right? There's a wide array of partners, not to mention the national labs and universities we're partnering with to develop these products and to test these products. So we're all working together with the goal of improving the safety for the reactors to demonstrate that, because that's going to be critical to nuclear success moving forward and to be sustained moving forward as well. So it's something I believe the industry as a whole and Westinghouse specifically as our part, we're looking to develop and maintain these benefits throughout the extended burn-up window that we are pursuing.
Great, thanks for that. John or Rob?
Sure, I'll just add, I think it's important to note that our plants are very safe today. They're designed and constructed in a safe manner. They're regulated by the gold standard of regulators. And so Senator Feinstein and Congress gave us a bold goal to go and try to improve our fuel. I think that's a great goal for us. And I have spent enough time working on understanding the performance and the benefits of these fuels going forward that I am confident that at the end of the day, we will achieve the safety benefits that have been requested by Congress and have been kind of that ambitious goal. We will achieve that. And on the opposite side of that, we will also have some benefits for our customers as well. So this is really a win-win. We're going to improve the safety of our plants, but we're also going to improve the cost effectiveness of our fleet and improve that for our customers. So I'm very confident at the end of the game, it will not be a zero-sum game, that we will achieve all of the goals that everybody has set out to achieve in this program.
Great. Thank you for that, John. Rob?
Yeah, I just expand on those 2 points a little bit more to say that, as John and I mentioned, the fuel technologies have evolved over the decades, and with that, the various safety margins. And so with ATF at even higher burnups and increased enrichment, those safety margins are going to be conservative, of course, but as we mature the deployment of the technologies and be able to understand their behavior more and more through pole side examinations, through hot cell examinations, through testing, we'll realize the conservatisms within the current safety margins, as well as any kind of extension to higher burnups.
Great. Thank you for that. Kind of teeing off of this, I want to start this next question. I think I want to start with Marilyn, and this is partly kind of about reactor licensing. And John, I think, and potentially Zach could kind of weigh in here too, right? So higher burnups can mean a change or even an increase in potential source terms. So, you know, how is NRC looking at higher burnup with regard to considering the impact of both accident frequency and potential accident release size? How's that going into, this is really kind of on the nuclear reactor regulation side of the house. But how are we evaluating the use of these fuels in kind of operating reactors with regard to, a different kind of accident scenarios?
So I'll start. I'm not an expert on Part 50, but I'll try to say what the NRC team is doing for Part 50, and I think they've done a great job about looking at the source terms, what that means when it relates to the near-term concepts about chromium-coated dope pellets and FECRL. We're assessing the information we have and whether we need to conduct additional research on that part. We've conducted 2 purges so far, and to identify any phenomena that we've missed or that our guidance needs to supplement on to make sure that we cover all the important and risk significance phenomena. So I'll say to that much and let others talk about it.
Okay, great. Thanks, Marilyn. John, do you want to touch on that a little bit?
Sure. So I'll add, I know that the NRC is in the process of revisiting its regulatory guide for the alternate source term, and with the intent of increasing the burnup limit within that regulatory guide. We're supporting that effort via the comment process and working to ensure that the concerns of the industry are addressed as we update that. But ultimately, when we move forward to license our facilities with these new fuels with higher enrichment and higher burnup, we're gonna meet the regulatory standards to ensure that we continue to operate and safely for the folks that live and work at our facilities. So, that is absolutely the goal. And so we're going to continue to meet the requirements as we change the burnup limits on our fuel. And we're, working through that process now with the regulatory guide update.
Okay. Well, I'm going to transition here. We're going to do just probably a couple more questions, and honestly, I'm saving the last one for myself. So, kind of with that in mind, we talked earlier about this, and I keep coming back to this because I think it really, in a way, is kind of the crux of the matter, the who jumps first, the chicken and egg problem. We talked a little bit about the financial aspect of that, right? How do we kind of, where do people kind of band together to create the demand signal to drive potential changes upstream, right? But I think there's also, I touched on this too, and part of what makes this a multidimensional, almost science fiction chicken and egg problem is that there are kind of regulatory and technical challenges in this space too. So I was wondering kind of if Rob and Zach could kind of talk on outside of the financial aspects of this, kind of how you see some of these other regulatory and technical challenges as well.
I'll start. Thank you for the question. So any new technology, any new fuel technology has to be measured against the current regulation, and those are the ones listed in the SRP Chapter 15, and so you have to consider. As I mentioned before, corrosion of the clad, hydrogen pickup within the clad, any kind of plastic deformation below 1% strain within the clad. centerline melting, preventing centerline melting during various operational occurrences, and then of course, going to the design basis accident criteria that are also tied to corrosion and hydrogen pickup as part of the current zirconium-based clad technologies. And so, any new fuel technology is going to need to look at that. And the coated zirconium alloy cladding is of course, as Marilyn said, a small iteration in all the series of iterations that have occurred throughout the industry. And maybe FECRL, the iron chromium aluminum alloy is something different. So we have to consider any new phenomena associated with it. And then, of course, going to the longer-term ATF technologies like the silicon carbide, like the metallic fuels, the high-density fuels. There are undoubtedly going to be new phenomena that we have to understand and be prepared to develop the technical basis that will then drive to changing any kind of regulatory guidance and limits. So those are the things that need to be first and foremost on our radar screen, because those are long lead time activities to help inform the industry and the regulator.
Yeah, that's great, Rob. Thanks for that. And I really appreciate your emphasis on the importance of research facilities at Department of Energy facilities, universities, and other places as kind of part of the overall ecosystem that enables these potential changes. So I appreciate that very much. Zach, I don't know if you wanted to weigh in here a little bit or not on this question.
Yeah, I could. I want to leave you some time, though, so I'll be really quick.
Don't worry about that.
All right. So the big gap for us to get to the higher burnup, high enrichment is, of course, the manufacturing facility and the modifications there needed. It's going to be a significant investment. So as Steve mentioned and John mentioned, we need to make sure that there is that demand and we have that appropriate level of demand to move forward with that investment. The next thing we need to do is really make sure that our schedules align in the development. So line out all of those key paths, those key interactions with all of the key players, with Steve and Urenco, with John, the utilities, with Rob, and the underlying research that goes in. And then, of course, throughout with the NRC. When do we plan to put our licensing material to the NRC for review? When will we get those key pieces of data that are necessary to license our products and bring them to market? So that's really at a big picture, my perspective. So thank you.
Yeah, thanks for that, Zach. I really appreciate it. Anyone else want to weigh in on that? Okay. All right. Well, I think the last one was, what does the commission think about ATF, and how are you as the new chairman guiding staff activities on ATF, and is it a high priority for you? So let me say this. I talked about in my plenary speech yesterday that I had 3 priorities, and actually they're the exact same priorities. I have the exact same priorities as chairman that I had when I came in as commissioner in June, or what I call the 3 A's. And the first one being kind of advanced reactors, and the second one being accident tolerant fuels, and the third one being academic programs. And those all kind of tie into this session together. And you know, I was focused, it's certainly the accident tolerant fuel program, because it was started by Senator Feinstein, and when I worked for her and for others on the appropriations committee, it remained a high priority. But I also took a personal interest in it. There was nothing saying that I had to bring that over into my tenure here at the NRC, but I did, because I think it's an exciting program. I tend to be, as staff are learning, as I go out and talk more, I tend to be an optimist. One of the things I tend to also be a technological optimist about a lot of these things, and I'm very excited about the work that's been done. And as I learn more about what's being done in the NRC to get ready for this, I'm consistently impressed with the way the staff are adapting and using risk-informed techniques and really working together across the agency. This is something that, you know, may have started in the Office of Research, but now has heavy involvement by NMSS, as well as the Office of Nuclear Reactor Regulation, as well as some participation by NSER. And I think that kind of breaking down stovepipes, which is what we're seeing kind of across in the private sector as well on this effort is really important and critical to success. So I really couldn't be more excited about this effort in terms of safety and public confidence and really all of the aspects that we've talked about today. So how can I support that? I can support it by, talking about it in my RIC speech and hosting sessions like this. When I saw this one, all the commissioners kind of got to choose a little bit about which RIC sessions they wanted to chair. And, there was no question. I was like, I'm all in on this, especially with the great panel that we've had today. People on the utility side, on the fabrication side, research, enrichment, and of course, from the NRC itself. And I'm just incredibly pleased to have done this. I appreciate you all very much for joining us today and for the great discussion. And I hope you enjoy the rest of the RIC. Thanks, everybody.
Thank you.